And it's code in the D to give the keyboard a punch. Then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean. And it's, oh boys, can't you code it? Program it right. Nothing ever happens in this.
Welcome back to my Stata video series. We've been looking at using the regression commands in Stata, and as we said in another video, the regression command itself is quite simple to use. The complexity comes up in the post-estimation commands. That is, there's a set of commands that you can choose to use after you estimate a regression model that shows you different things about your model. And we're going to look at some of those in this video and others after this one. So I've already got Stata up and running. As usual, I'm using the General Social Survey, and I've selected the Prestige 80 occupational prestige variable, marital status, gender, age, race, and highest academic degree earned, and I've gone ahead and subsetted my data already. So I only have those variables for the year 2010. I'm going to go ahead and estimate my first regression model. I'll regress the Prestige 80 variable on all of the others, and like I like to do this, I like to highlight the line and then come up here and click on the execute button here, and we can see we get a lot of computer output. We're not going to spend any time interpreting this output, but obviously this is the first step in your regression modeling, is to produce the regression model itself with the relevant variables and to begin the diagnostics of how well your model works. So the predict command is the first post-estimation command that I want to look at today. The predict command is very simple. It's simply the word predict followed by a variable name that you choose, and then a comma followed by an option. And we're only going to look at two different options today. The first is, let's say you wanted to produce the predicted values, or the y-hats, based on your regression model. And you could do this by hand by writing a long formula using your regression coefficients, and you would have beta, your constant, plus beta hat sub 1 times your variable 1 plus beta hat sub 2 times variable 2, and so forth. You'll get rounding error, and it's subject to just general programming error. Well, Stata has a command built in. You can see down below I'm using the predict command, and I've got predict y hat, so I selected the variable name y hat, comma xb. xb is the default. I could have just said predict y hat, but I'm just showing you here that what the default is. And then I'm going to do I'm going to use the tab stack command to show you the average y hat by academic degree. So we'll go ahead and run these two commands. Okay, so we went ahead, and you see there's really no output. There's just confirmation that the predict command ran. And so now I have a new variable called y hat, my predicted value for each observation, and I can do things with it like calculate the arithmetic average of predicted occupational prestige by high school, less than high school, and all the other academic degrees. There's other ways of doing this in Stata that are actually better. I think the margins command is much better, and that's going to be the subject of a longer video. Let's move on and look at the next predict command. When you do your regression models, you probably learned in a statistics class that the shape of the residuals is sometimes important for if you're going to be using tests of significance. We'd like that distribution of the error term to be normally distributed. And we can check that by creating the residuals, which we know are the difference between the predicted values and the observed values. But Stata, again, has a command to do this automatically for us with little effort and real little programming skill. Again, we're going to use the predict command, and this time I'm going to use predict and call my new variable e for my error term. You could call it r or resid, any name you like. And now the option I'm going to choose is not the xb option, but the residuals option. We'll go ahead and run that command. When we go over and look at that output, you'll see that again there's no real output here. It's just confirmation that the command ran. Now I'm going to go ahead and create three graphics. I'm going to do a kernel density plot of the residuals with a normal distribution plotted over it. I'll do a Q-norm plot and a P-norm plot, two different kinds of graphics that allow us to assess normality. Let me go ahead and run all three of these graphics, and we'll look at them quickly. So here's my kernel density plot. You can see that there's a little bit of extra space in the tails at both ends, although the lower tail looks pretty good, and that in the middle that we don't quite fill that normal distribution. You can get the same information from both the Q norm and the P norm plot. Those plots are sensitive either to the tails of the distribution in the case of the Q norm plot, or to the center of the distribution in the P norm plot. So you can see here, just quickly looking at Q norm, on the right hand side and the left hand side we see these deviations from that straight line, which would indicate a perfectly normal distribution. Let me close this plot, and that brings up our P norm plot. And so you can see here that the P norm plot, while is less sensitive to deviations in the tails than it is in the middle of the distribution, and so again, sort of in the middle of that graphic, you can see that the indentation or the depression that we see in the kernel density plot. Well, there you go. That's our first post-estimation command, the predict command, with two options. We can create predicted values. We can create residuals. I hope you found this helpful, and if you have any questions, please let me know and I'll do my best to answer them.
And it's code in the D to give the keyboard a punch, then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean. And it's, oh boys, can't you code it? Program it right. Nothing ever happened.